So let's move to the seed then, which I gave you last time. Okay, so the first question, right? How many happy have solved it? I'll just go through the hint of each of this question as a list in the start. I think that should work. Can you quickly tell me what is the approach? Manoj, can you first? I'll start with you. What is the approach that you tried, Manoj?
Yeah, so what I did was first I wrote a for loop. In that, I found the maximum value and the minimum value of that array. After that, I came out of the loop and I again wrote one more for loop. And in that, if the array of I, like the first element, I'm iterating one by one. If it is the maximum value which I have right now in my hand is, then just make a swap of it. So the max will be placed at the first position of the array, and same for the min as well. So in this way only I did.
So what is the time complexity of this one, Manoj?
Okay, so first will be n, and then yeah, I think n only.
It will be not n, right?
Sorry.
N square, right?
Yes. We are writing two loops. Okay, sorry.
Okay. So be very clear about this time complexity.
Yes. N is square.
We
Correct.
have solved so many complex time complexity questions. This is very simple, so you shouldn't do wrong in this one. Right? Okay. So Paritosh, is it same or you have tried something different?
Yeah, like I have what I did, I sorted the array, and then I took the right hand side and the left hand side. So I incremented and decremented, and based on that, I got these values.
Perfect. I think this is right. So because in that case, what will the time complexity if you do the sorting? Paritosh, what was the time complexity in that case?
So if I do a quick sort where the time complexity is n log n.
Perfect. Yes. So the key is, yes, I got your point, Paritosh. So basically, we should do a merge sort or quick sort, which is n log n. And if you do a sorting and then do it, the time complexity will come at n log n. Manoj, your approach was right, but that is a brute force way of doing it. So we can always optimize it. We can sort the array first. What we do is that we sort the array first, and then you take the last element of the array, which will be the largest, and then take the first element. So it will be the smallest. Then you take the second last element, and you take the second element. Then you take the third largest element, and the third last element, and you take the third element. Then you take the fourth last, and then you take the fourth element. And you keep on doing like this once you have, iterated it through the complete array. So this will alternatively sort your array in the n log n time. Is it fine?
Yes, sir.
Perfect. Now the question number 2, I think we can park it question number 2 as of now. Okay, because this involves something called priority queue, which we have not studied so far. So just park this question number 2 as of now. We'll come back to this when we study the priority queue and the heap in the future. Question number 3. Anybody who has solved this question number 3? So basically the idea that we have to use in this question is that first of all you have to find the absolute difference for each of the elements. So I have an array 10, 5, 3, 9, 2, and with 7 if I have to find, so the absolute difference will come at like 3, 2, 4, 2 and 5, right? And now somehow I have to maintain this mapping between the initial element and the absolute difference. Okay, so I should have a mapping corresponding to each of the absolute difference. I should know, like for example, 7 and 10, absolute difference is 3. So I should know 3 is pointing to 10. Similarly, 7 and 5 difference is 2. So the 2 is pointing to 5. So I should have a mapping which maintains this relationship between the absolute difference and the actual element it is for. Okay. And then what we need to do, we just need to sort the absolute difference, and accordingly you will have to change the position of the actual element. This is the only logic that you guys have to apply. So please try this question again based on this logic, and only if you are not able to solve it, let me know. We'll solve it in the session. Okay, this is the logic. Clear? What you need to do, you need to find the absolute difference of each of the element. Try to maintain a mapping between the absolute difference and the actual elements. Sort on the basis of the absolute difference, and accordingly change the position of the actual elements also. When the absolute difference is sorted, what the array you get of the actual element will be your answer. Right. So this is what you have to do in this one.
In this problem, actually, I used dictionary. Dictionary, like in Java, it is known as hashmap.
Yeah, you can use dictionary, no problem. Yeah, you can use dictionary.
So what I did that I used a key value pair.
Okay.
Based on that, I sorted the array. Like what I did, I had used a dictionary and the index, the value, and the absolute difference in the dictionary, and then based on that, I have sorted the array.
Okay, that makes sense. But what I'll encourage you guys to use is that since we have not studied map or dictionary as of now, which we'll cover in the coming sessions, in the future sessions. So far, we have only studied about the array. So can you think of using a 2-dimensional array where the first column will be the key and the second column can act as a value, and try to use just a 2-dimensional array to solve this instead of using anything that we have not studied so far? I understand like solving this using dictionary, you can solve it. There's no problem in it. But I want you guys to only use those things which we have covered so far. So we have only covered about the array. So instead of using a dictionary kind of data structure or a key value kind of data structure in any other of the language, can you just use two-dimensional array where the first column is basically the difference, absolute difference, and the second column will point to the actual elements. Can we do that?
Yeah, we'll try.
Sure, Vishwa, sure.
Yeah, please try that. Okay.
Yeah.
Question number 4. First of all, I explain the question and then I'll ask this question. So basically, what you have to do is that suppose this is the array that has been given. Okay, just like in the wave, what happens when you go to Goa and you are at the beach side, right? What happens? Sometimes the crest and the trough happens, right? The high tide and the low tide happens. So normally, what it is trying to say is that all the elements of the odd position should be more than the elements at the even position. Sorry, element at the even position is more than the element at the odd position. So the 0 is 10 and even it is 5. So basically odd position is this one and it is more than both the even position element like 0 and the 2, and similarly like this. So it should like larger, smaller like this. So first large, then small, then large, then small, then large, then small. Like this it should be formed. So this is the meaning of this question. You have been given any array like this and you have to convert into a waveform. So first the large element should be there, then the small, then again large, then again small, then again large, then again small. This is how you have to arrange it. This was the meaning. Make sense? Now, is it clear?
Sir, can we use question number first concept to this question?
Definitely, you can use. Very nice. So, what will you do in that case?
First, I will sort. Then.
So in that case, the time complexity will be n log n. Very nice. You can solve it, but the time complexity is n log n. Can you think something better to improve the time complexity? Anybody who has solved this? What you need to do is that the first approach which Jaheer has told, I think it's very nice and that will work. But that will take n log n time. If we have to improve it further, what we can do is that always try to focus to move from left to right and always try to focus only on the odd positions. So my first odd position is 1. So I came at 5. Now I see 5 is already smaller than both 10, both its neighbors. So it is smaller than 10, it is smaller than 6. I don't have to do anything. I jump to the second odd position element, which is 3. Now at the 3, I see 6 is greater than 3. I'm totally fine. But I see 2 is now smaller than 3. So what I do, I swap it. So I bring 2 here and 3 into the right. Right? And then again, I move to the 5th position. So what I need to do, you only go to all the odd positions and see if your neighbors are greater than you. If they are greater than you, you are all fine. If they are smaller than you, then swap with your neighbors. And this you can do in a linear time. And this way, if you do, you can sort it in the waveform. Make sense? Just try this out. What you need to do, go to all the odd positions, check your neighbors. If your neighbors are already greater than you, don't need to do anything. If your neighbors are smaller than you, then you just have to swap with your neighbor. And that's all that you have to do. So this can be done in a linear time. Make sense?
Yeah, Vishwa, but in that sense, suppose 1 is a very smallest number and it is lying in the last, then how we will bring it before? Because as I can see the other outputs like 10, 5, 6, 2, 23.
Okay, tell me one. So let me do this. Tell me give me an array. Give me an array which you want me to do that.
Take the same array and put 1.
Okay.
And 1 in the last.
Okay, 1 in the last, right?
Yeah.
Okay. So first I came at the I equals to 1. Okay?
1, yes.
So this is the position. This is already more than
This
10.
is correct. Yes.
Doesn't work. Then I came at to I equals to 3. I came here. Now
Correct.
6 is greater than 3, no worries. 2 is now smaller than 3. So I repeat here. I bring 2 here, I bring 3 here. Then I came to 5. 5 is what? 0, 1, 2, 3, 4, 5. 5 is like 20.
20.
20 is greater than 3. No, so this should not work. So I will bring 20 here and I'll bring 3 here.
Yes.
Right. Now 3 is smaller than 100. It's totally fine. I go to the 7. 7 is 80. Now 80 is smaller than 100. That is totally fine. But 80 is greater than 1. So what I do, I bring 1 here and I bring 80 here. Now you see it is in a waveform. Greater, smaller, greater, smaller, greater, smaller, greater, smaller, greater.
Yes.
Right? So this way we can do with the linear time. Everybody is clear? Golo, Jaheer, Manoj, Pradosh, Vivek, are we good?
Yep.
Perfect.
Yes.
Okay. Then this question number 5. Okay. Question number 5 says that, again, I'll come here. Question number 5 says that, so suppose I have it is like this 1, 3, 5, 7, and so suppose this is of the size 4 and this is of the size say 4 plus 3, and then I have 2, 4, and 6. Okay. Now, normally, this is basically an extension of the merge sort. In the merge sort, there is something called merge function, right? In the merge function, basically, you take two sorted arrays and merge it, right? And that happens in a linear time. Now, in that case, what you do, you use a temporary array to merge the two sorted arrays and then convert into a single array. This is what you do in the merge sort merge thing. Okay. In the case, guys, you have not clear, please go through the merge sort merge logic. How do we merge two sorted arrays in the merge sort? That is very important. And last time also I told you that nobody will ask you the merge sort directly, but there will be questions which have the concept you will utilize it. So this is the question which utilizes the concept of the merge sorting. But now the problem here is that you are not allowed to use any additional array to do the merging, because you have said that my first array is already having enough space to accommodate the elements from the second array, right? So the first element has space of 7, but it has only like 4 elements, and the second array has 3 elements. So you don't have to use any extra space, and you have to somehow put this into the first array and put it in such a way that the array is sorted. So it should become like this: 1, 2, 3, 4, 5, 6. Can you guys think about this merge sort approach and then try it if you have not tried it again, because then it will strictly defeat the purpose of the question. So I want you guys to look at the merge sort again and try to apply this question. But when you're trying, don't try to blindly apply the merge sort, because this question is different from the merge sort. So what you have to do, you have to little modify the merge function of the merge sort to do it. So little think out of box, try to tweak it a little and then apply in this question. Make sense? Shall we move to the next one? Will you guys try it again?
Yes, sir.
Perfect. Now, sort an array which contains 1 to n values. I think it's very simple. Did you guys try this?
So I did that, but what is the without replace with 1 to n numbers? Like, what exactly you mean with that?
So basically, it means to say that you don't, since it is 1 to n only, so they are telling you don't just put 1, 2, 3, 4, 5, 6, 7. Just print the number 1 to n. This is what they need to say that. Instead of that, you can just use this. So what you can do is that you can just write a loop in which array I is equal to I plus 1. This if you do, then we create a sorted array. Array of I equal to I plus 1. That's all. Because the array I is 0 and the element at 0th position should be 1. So you just write a loop in which array of I is equal to I plus 1. So this will sort an array containing 1 to n values. Make sense? It's a very simple statement.
Yeah, fine.
Question number 7. Sort 1 to n by swapping in the adjacent elements. Okay. Now in this question, normally what we have seen, right? So again, you remember I put a stress on figuring out how many swappings are happening in the bubble sort or the any kind of sorting is there, right? So any kind of sorting algorithm that you do will require the swapping to happen. Whatever the sorting algorithm is, whether it's a bubble sort, selection sort, insertion sort, merge sort, quick sort, anywhere, you'll see that at some time we'll do some kind of swapping, right? Now this question says that there's an array that is given to you, and there's another array which says that whether the elements can be sorted or they cannot be sorted, right? So for example, if the bi is equal to 1, it means that ai can be swapped with ai plus 1. But if bi is equal to 0, it says that it cannot be swapped with another array. So you have to basically try, sorting the first array, and whenever you're sorting, some places you will have to swap it. And whenever this, whenever you want to swap the elements, you have to check the array B. And if it is 0, you're not allowed. So if you need to sort and you're not allowed, it means that you cannot sort the array. This is what you have to do in this question. So you have to, try to sort the array. And when you're trying to sort the array, before you're doing the logic of swapping, you have to check whether the swapping is allowed or not. If you have to swap and you're not allowed to swap, it means that it cannot be sorted. This is the meaning of this question. Now is it clear? Can you guys give it a try? What do you need to do? Try to sort the array, and while doing your sorting, you have to always swap it, right? So before swapping, you go and check in the array B whether this swapping that I'm trying to do is allowed or not. If it is allowed, I'm totally fine. If it is not allowed, then I'll say this cannot be swapped. Make sense? Is it clear, guys?
Yep.
Yes.
Perfect. Sort an array containing 2 types of the elements. Okay, now this is only 0 and 1 is there. There can be multiple ways of solving it. Anybody solve this question number 8?
We can have left index and right index. If in left index, if we found 1, and in right index, if we found 0, then we can swap it.
Very nice. So this is known as the 2-pointer approach, and this is a very strong concept. In the next session, I'll actually try to solve a problem with the 2-pointer approach and explain it, because this is very important. What happens in 2-pointer approach? You keep 2 pointers, one in the left part of the array, one in the right part of the array. And you keep moving from left to right till you find 0, and you keep moving from right to left till you find 1. And as soon as you find 1 in the left and 0 in the right, you swap it. right? And this is how you do. So if you do this way, you can sort the array in a linear time in a single traversal, So this is how we do question number 8. Question number 9, sort by element by frequency. Now again, this question is similar to the question that we discussed, in which we have to sort elements by the difference, right? We discussed about the question, right? Sort an array according to the absolute difference. Question number 3, right? The similar concept we can apply here in the question number 9. Here the only thing is that instead of the absolute difference, we have the frequency. So we should create a mapping between the frequency and each of the element. Then we sort it with the help of the frequency and then get the result. Make sense?
Yes, sir.
Now question number 10. Anybody tried question number 10? Question number 10. The question simply means that, whenever you have an array, right? Whenever you have an array and whenever you have to do a swapping. When you do a swapping, we do a swapping when the right element is smaller than the left element, right? That is only when we do a swapping. And that swapping is what they call it as an inversion, right? So basically you have to figure it out, given an array, how many times in that array you will have to do the swapping. This is what you have to figure it out and tell. So it is saying, formally speaking, in an array you have to figure it out how many times the swappings is going to happen, right? And if you can tell the number of swapping that can happen while sorting the array, this will give you the count of inversion. So basically you have to tell the number of swappings. And again, I stressed a lot when I was talking about the sorting algorithm, in which I told you that how many times the swappings are happening. So if you apply the same concept here, if you try to figure it out, find the exact count of how many swappings happened, that will give you the count inversions in an array. Make sense? But when you are doing this, you have to do it efficiently. Don't try to do a brute force approach. Try to think smart and try to find this number of swapping that you'll have to do while sorting it in a smarter way, so that you don't take the brute force approach. Can you guys try this question now?
Yep.
Perfect. So I think we have a good number of questions that we have solved, and we have few questions as assignment for the next lecture. So please try to go through this, and there are few more concepts which is left in the array, which we'll try to cover in the next session. And once you're done with this seed, please give me a message on that group, and I'll send you more questions around the array. So the target is to solve as much questions as possible. So the more you guys will be able to solve, I'll try to give more and more questions. So it all depends on you guys, that how how open you guys are and how many questions you guys can solve. Okay. In the assignment, I will only giving you the practice questions. So all the concept that is needed to solve this question will be covered in the class, so you don't have to worry. Only the practice question I'll be giving you the assignments. Any questions? Any suggestions?
No, Vishwa, just this approach is good for me. Like, first we will discuss the concepts and then quickly we'll take the hints and complete the sheet like this.
Perfect.